Today we're doing some preamble stuff, thank you, of what's going to be in the circle unit, some important definitions, and some important facts from previous units that you will need. We're going to do the definitions thing after this in a little bit of a different way. Now, the first thing we're going to do is talk about naming an angle. So there is more than one way that you can call that angle. Does anyone know one way that we could describe that angle at the top? Angle A. So we could call it, and we use that little angle symbol to say angle A. Does anyone know another way we could say that same angle? Angle BAC. So sometimes we need to use 3 letters to describe an angle because there might be other lines coming off of this. If I call this E and F, if I say angle A, I don't know if I mean this angle, this angle, this angle, or this angle if there's more than one line. So sometimes we need 3 letters to describe it. In this case, probably the best way would be just angle A because there's just the one letter. But you could also use angle BAC. And a third way, angle CAB. Angle CAB. Okay? What do angles in a triangle add up to? 180. Did you know that angles in a straight line also add up to 180? Because a straight line is halfway around a circle. And since there's 360 degrees around a full circle, halfway around a circle would be 180. So if you wanted to go from here all the way to here, this is 180 degrees. Now they're telling us angle DAC is 120. So what you would do in a question like this is you would label where that 120 degrees is. Is the 120 degrees here or is it here? So we go, oh, if I go D, then A, then C, this would be my 120 degrees. So what is angle CAB? 60 degrees. So you would figure this out. It has to add up to 180. 180 minus 120 would give you 60 degrees. Opposite angles are equivalent. When 2 lines cross, the angle here is going to be equal to the angle here. And when we show that angles are the same, we can do that. We can draw a little curvy line like that. Sometimes you'll see here I would have to use 2 curvy lines to match up with this one because I already used up 1 curvy line for the green ones. So the opposite angles of 2 lines that intersect are always equal. Yes? Like if you measured that arc, yes. But we generally, when we do these little lines, and sometimes you'll even see them mark it up like, oh, I'm going to put 1 dash here and 1 dash here so I know those are the ones that are the same. Have you ever done that on sides to show that 2 sides are the same? Make a dash and a dash? You ever seen that before in triangles? Or like if I drew a rectangle, I could say that those 2 are the same with a little dash, and I could use double dashes here to say those 2 are the same. So that's some notation that sometimes comes up in mathematics. When 2 lines cross, there are 2 sets of opposite angles. So we could write this, if we wanted to write this, we could say angle POQ is equal to angle ROS. And the blue ones, we would say angle POR is equal to angle QOS. That's all we have to put for that one. It's just showing that when angles are opposite. So I'm going to add an example here. I'm going to draw two lines that cross. And I'm going to tell you that this angle right here is 43 degrees. Can you tell me any other angles? Yes. The one across from it is 43. Good. Can you tell me any more answers? If you subtract that from 360, that would work. But there's an easier way. There's an easier way to find this angle. How am I going to find this blue angle? Okay. They're in a straight line. Angles in a straight line add up to 180. So this one, 180 minus 43 is 137, which makes this one 137 as well. So if you know one angle when two lines intersect, you can find them all, which is really powerful. Yes, you would do 360 minus those two and then divide it by 2 would work out perfectly as well. Find the angle that is missing in the following triangles. Okay, I'll give you a head start on this. Can you find the angle that's missing in the following triangles? Well, there's only one angle that's missing in the first one and only one angle that's missing in the second one. Yeah, the square equals 90. Good. So maybe you want to put that in, that this equals 90 degrees. And you should be able to tell me what the other angle is. What's the key fact for figuring out what the other angle is? What key fact do you need to figure out what the angle is that the sum of all the angles in a triangle always adds up to 180. So what does it add up so far to? 120. What would you need? 60 more. What do these two add up to? 100. So what would you need to make 180? 80. Perfect. So here's using the line thing. I put a double dash there and a double dash there to say those lines are the same. On the second one, I have a double dash here and a double dash there to say those lines are the same. These are not drawn to scale, okay? Can you see in the second one, this is not drawn to scale. This doesn't look the same length as that. In mathematics, sometimes a drawing is done quickly, and you label things, but they may not be exactly to measure, right? Because if someone says, hey, can you draw a right angle triangle with an angle of 30 degrees? I'd say, okay, I'll draw a right angle triangle with an angle of 30 degrees. Is that angle perfectly 30 degrees? Absolutely not. I tried. It might be close. It might be, oh, it looks like 27.6. It's a little bit off. But in math, it would take us forever if every time you drew something when you're doing your work, it'd be like, oh, I'm sorry, that's not perfect. Start again. Okay? Now, sometimes the drawings are really off. Okay? Here's an example of a triangle where the drawing is really off. Tell me what's wrong with this picture. Oh. That is really off, right? If I switch the numbers around, it wouldn't be too bad. But I made the long side short and the short side long. Okay? If you're drawing a diagram and it's not to scale, that's sometimes allowed. So according to this second one, this length is the same as this length. Do they look the same? No. But according to the diagram, we're going to say that they are. Yes. Okay. So, now that we've talked about diagrams not necessarily being to scale, the first one looks not bad. Do you see these triangles look identical, but the angle changed? So something's wrong with one of them, definitely. Probably both of them. But isosceles triangles have two congruent sides. So two sides that are the same and two congruent angles. So if this is an isosceles triangle and these sides are the same, then this angle and this angle are the same. And in this one, if these sides are the same, then this angle and this angle would be the same.
Wait, so it's the one, but how do you figure out what angle is the same? Oh,
The ones at the, not the one in between the sides that are the same, the other two angles. So if I would draw a perfectly, and say this side and this side are the same, then it would be these two angles are the same. If I would say this side and this side are the same, then it's these two angles. And if I said this side and this side are the same, then it would be these two angles that are the same. So it's not the angle in between the congruent sides. It's the angles at the bottom. Okay? So, can we find all the angles that are missing?
Yeah.
What would you do in the first one?
You minus 37 by 180 minus 37,
And then that gives you,
by 2.
that would give us 143. Then that has to be split evenly between those, so I could take 143, divide it by 2, and both of those angles is 71.5 degrees. In the second one, can you see there's one angle you can find right away really quickly? Since these two have to be the same, if this one's 48, that means this one's 48. And then how would you find the last one? You could take, to find the green one here, you would take 180 minus 48 again, and you would get 84 degrees. And that triangle in particular is not drawn to scale. The reason that isosceles triangles come up quite a bit in circles is we're going to have circles. That's pretty good. We're going to have a center of our circle. We're going to have points on the outside of the circle. Okay? And some of these points are going to be connected. Let's go. A, B, C, D, and we often call O the center. Okay? There, I drew, how many triangles are on that picture that I drew? Close? No. How many triangles? Let's label them. You see one, tell me a triangle. Triangle. Yes, BDC is a triangle. Good. AOD, good. AOB doesn't have a line join in it. ABD. That was the one most people missed. It's still, if ABD is this, if I highlight it in yellow, is that a triangle? Yes, it is. Okay. Which ones are isosceles? All of them? None of them? Some of them? One of them? Two of them?
All of them.
O is the exact center. AOD is isosceles. And how did you know that one was isosceles? Well, right angle, you can have a right angle isosceles triangle with 45 and 45. This length is a radius of a circle, and this length is a radius of a circle. So that makes AOD isosceles. ABD is not isosceles. It could be close, but I don't know for sure.
But wouldn't it be because if it was a perfect circle?
If it's a perfect circle, and I measure these sides for you, if I measure the sides with a ruler, this one is 13 and a half inches, 13.5.
But that's not a perfect circle.
And this one is 13.25. It's close. It looks like it.
Perfect circle.
Yeah, but I'm not drawing things to scale. So if it's not drawn to scale, you couldn't say for sure that ABD, you can't say that it's isosceles. The only thing you could say for sure is if O is the center, then OA is a radius. And OD is a radius. And radiuses are always the same for a circle. That makes that triangle AOD isosceles. All right, last topic before we get to our next activity. Pythagorean Theorem. A squared plus b squared equals c squared. And the c is always the hypotenuse, always the longest side. So, can you find the missing side in the following triangles? Oh, and next year in grade 10, you will learn Sohcahtoa, sine, cosine, and tangent, and be able to figure out those angles. No matter which math you decide to take next year, Sohcahtoa is part of it. Yeah, you have no idea what it's like, some kind of chant. You'll find out. Sohcahtoa. I'm in a good mood because I got lots of work done this morning already. Makes me feel good. All right, how did you do on the first one? This would be the c because it's a hypotenuse. So a squared, 5 squared, plus b squared, 10 squared, equals c squared. You go to your calculator and 5 squared is 25. 10 squared is 100 equals c squared. And so you would get c squared is 125. How do you get rid of the squared? You square root. Now, normally when you square root both sides, it could be a positive number or a negative number. But when you're dealing with triangles, the hypotenuse is a length, so it's always positive. So we would take the square root of 125, which is 11.18. Oh, I was going to say 11.2. Shoot, I was close. And it keeps going though, right? We're rounding this. This would keep going. Not yet, not till next year when you learn Sohcahtoa in grade 10. If you wanted to find this angle, you'd have to go to your calculator, find out how to push this button and do 10 divided by 5 inside of it, and it will tell you what that angle is. So if you can figure out how to get 10 with a little minus 1 on your calculator and do 10 divided by 5, then you can find the angle. And we would use tan because in the Sohcahtoa, we know from this angle, this is the opposite side, and this is the adjacent side, and this is the hypotenuse. So we know the opposite and the adjacent, and the only one that has an O and an A is TOA, so that's why you use the tan button. Did anybody find that tan with a little -1 on their calculator? And then do tan over 5, and we could find that angle. Now, in this one, what letter should I use for this side? Two things. In the a squared plus b squared equals c squared, this would either be a little a or a little b. Did you know that when you actually label triangles, there is one, in this triangle that's DEF, there is one letter that should be used for that side. Do you know what letter that would be? This should be letter little d. When we label triangles, we always label sides with a little letter opposite of the big letter that's the angle. So do you see how little d is opposite of angle d? So that's why we would say this is little f and this is little e. Which is the hypotenuse? The 8, the d, or the 15? Which is the hypotenuse? That's your hypotenuse. So when setting this up, it would be d squared plus 8 squared. Oh, yours is better?
Ours looks
More like 90. Mine looks a little bit bent.
yeah, yours, I was like confused. I was like,
I bent it on purpose just to get your head to be able to wrap around things, triangles not being the same way. This is side D. This is the one we don't know, little d. And the 15 is the hypotenuse, so an a squared plus b squared equals c squared. The 15 has to be on that side. Now, when we square these things, 8 squared is 64. 15 squared? 225, good. And then you subtract the 64 on both sides. And you would get 161. And so D is going to equal 12 point, I'm going to estimate 12.6. Well, how close was I?
12.68.
Oh,
So it should have been 12.7.
7 would have been a better estimate. Oh, if it was 12.688 and you rounded it, yes, you should write 12.69. I wrote the little dots at the end saying that it keeps going, then I wouldn't have to round it perfectly. Okay, so I'm going to end our video here.